Okay, everybody, it's time to get started. I am Joe Stewart, and I am just another Ron Paul spammer. Anybody? Any Ron Paul supporters? One guy, thanks. Thank you. All right, so actually this talk is just another Windows kernel Perl hacker. And hopefully by the time you leave here, maybe you'll be one too. So before I start, I just want to say that I know that some of you out there are kernel geniuses, and you live, eat, breathe, and sleep in Ring 0. I'm not one of you guys. I'm just a guy who likes to reverse engineer stuff and write crappy Perl tools. So keep that in mind when you're throwing those questions out there. So this talk is about a tool that I wrote basically to allow me to debug the Windows kernel. So if you use the conventional Windows tools, you're looking at setting up two systems, across a serial cable, a null modem cable, and doing your debugging that way. But basically, on one side, you've got the target system. On the other side, you've got the debugger, which is typically you'd be using WinBag, which is Microsoft's tool that's free, and it's a pretty good debugger. Unfortunately, I don't really like to use Windows when I'm doing debugging if I can help it. I try to avoid Microsoft tools if I can at all. So I said, hey, why not just go ahead and reverse engineer that whole serial protocol and write my own, and of course I like to write it in Perl. So I went ahead and did that. Fortunately, I didn't have to do a whole lot of work on the reverse engineering. Somebody had already, a couple of years earlier, done a pretty good write-up online, and that's you can find that in the paper on the Black Hat CD in the references section. Pretty good write-up on it. I needed a few things cleared up, so I went ahead and did a little bit of snooping and capturing of the packets and saw how it was all laid out. And that's essentially what the talk was supposed to be about, with a short demo at the end. But since it's now a turbo talk, there's not really enough time to go into the finer details of this packet protocol over the serial cable. So I'm going to skip all that and basically just go right into the demo. So the tool is called WinDPL, and you can call it WindPill if you want. So the same way they call it WinBag, so you can call this WindPill. So you can download it right now if you want to. I'll put the URL up there if you want to grab it. So if you want to download it, follow along. Feel free, if you brought a null modem cable with you, to go ahead and plug that into the laptop of the Windows user next to you. Just get them to edit their boot.ini file to put it in debug mode and reboot first, but feel free. All right, so the thing about the demo, another reason that I have to kind of just speed this along and just go right into the demo, is because I'm using VMware here, and I don't have two laptops up here and a serial cable, so I'm using VMware as our target system, and we can communicate with VMware's virtual serial port over something VMware calls named pipes, and it's really a Unix socket, but we can do that, but it's actually pretty slow in comparison to the actual serial hardware connection, which isn't all that speedy itself, but it works pretty well. So in order to go ahead and to establish this communication, we need to basically set up a sudo TTY so that we can communicate from our debugging client to VMware. And I have a nice little shell script I have here to run the program socket, which does that for us, just allows us to set up a sudo TTY to talk to that VMware socket. Can everybody see pretty well? Everybody got pretty good eyesight? All right, we'll see. How about now? Everybody see that? Ooh, ah. All right, so we'll go ahead and run that socket script here. And it basically just runs in the background, and we've got a sudo TTY on dev PTS4. So we'll go ahead and run our tool here. I've gone ahead and compiled a special demo version to use here that has a little bit of extra debugging output. So while it's sitting here doing and churning away, talking that serial protocol, you can actually see a little bit of what it's doing behind the scenes. All right, so it doesn't do much at first here. We just need to tell it we want to break into the running kernel. So we just type in break. And we've got a report back from the target system that there was an exception, and it's a breakpoint exception. It tells us where it is. So now we're actually, we've halted that VMware system, and we are in debug mode. So for some reason, the first time around, it gets a little out of sync with the protocol, so it works better when you start it up the second time. All right, so we should be able to, at this point, read and write registers, memory, and interact with the Microsoft Debug API, which is really what's doing most of the work for us. We're just having to talk the protocol and maybe read and write memory structures, but the actual hard work of setting the breakpoints and everything like that is actually taken care of by the API on the Microsoft's Debug API, which is on the target side. Let's go ahead and try to read a register. So we'll just type REAX and just see what the value of the EAX register is. And if we're lucky, we'll get something back. And if we're not, then that means that the protocol is, again, out of sync, which is the first thing that happens during a demo, is that everything goes completely wrong. There we go. Okay, so we're getting readings back from the other side of the serial connection. So let's see if we can see what the current instruction pointer is set to. So give it the EIP register as an argument to R. So our EIP, where we've stopped here, the operation of the system is 804.55994. So what we can do now is we can examine that memory if we want to. So we'll just dump it out. 804.55994. And we'll give it 40 hex. And so you can see here that this is the raw bytecode where the kernel stopped executing. The first opcode is a CC, which is an int3 opcode, so that's a software breakpoint. And something that would be really nice to have in any debugger would be a disassembly engine, and I have not implemented that yet. It shouldn't be all that difficult because there's already a disassembler, a library, the Bastard disassembler, which actually has a Perl example already. So it should be pretty easy to merge the two. I just really didn't have time for all of that. So we can do things here like set a breakpoint. So let's say that we want to set a breakpoint 2 instructions past where we stopped. Which I'm pretty sure is in the middle of another instruction, but we'll go ahead and do it. So, okay, it's set that breakpoint, and now we can go ahead and we'll just read that memory again and just confirm that that software breakpoint did show up. So we'll dump that memory. 8, 4, 5, 5. All right, the breakpoint didn't show up. Okay, wait on. I said the 2 pass. I didn't add 2. Why didn't anybody tell me? 4, 5, and 9, 9, 6. Oops, that's not what I want to do. All right. 8, 0, 4, 5, 5, 9, 9, 6. Now we have a breakpoint. Now we can dump that out. All right, so we've managed to manipulate the breakpoint, and you can see it reflected in the software where it's set a second int3. So we'll go ahead and clear that breakpoint because we don't want that to actually take effect. All right, so very simple functions like setting breakpoints and reading and writing, memory, virtual and physical. This is all taken care of by the Microsoft API. So, that's not very useful in itself. So what I did was basically take that framework and then write some macro commands on top of it, which is pretty much the same thing that you find in WinBag, is that they have these higher level commands, and you can extend it yourself if you want to, compile some DLLs and work with the API that way. But it's so much easier to do it in Perl, and so hopefully other people, take in the examples that I've already provided here and make their own macros. But one of these macros you can use, we can list the kernel modules, and this is something that actually takes quite a while. There's a lot of reading and writing and list walking that you have to do here, or not writing, but a lot of reading of kernel memory structures. So it's actually, if you go over and look at the VMware icon here, you can see that down in the tray there, it's actually pumping away on the serial port there, reading data. So it's basically started collecting now information on each module that's linked in into the module list in the kernel. And so we're just going to basically process through all of those and then spit out a list of what we have loaded and all of the various aspects of those. Does anybody have any questions at this point? Because this actually takes about 60 more seconds to actually run. Over here.
I'm assuming you're running this against XP. Have you done anything with Vista yet?
I'm actually running this right now against Windows 2000, but it does have XP and Vista offsets in the program if you look at the macros, and the debug protocol really hasn't changed. There's a few extra things you can do on Vista now. You can actually use a USB or a FireWire to do the debugging, but I don't have it implemented here. But yeah, you can use Vista. Okay, so we've got a list now of the modules. Just spit it out for us, and we can see each one of the name of the module and the base address and its size and entry point. Another type of macro that you can use as an example, if you're wanting to get into this, is how you would list processes. So we get the handle basically table, which has all the system handles, and we use that to kind of work our way down through and find the first process's eProcess block. And each process has this eProcess structure, and it's linked to every other eProcess structure in a doubly linked list. So once we find one of those, we can walk through the entire list. So that's what it's doing now. It's basically just reading through each eProcess and then locating the next eProcess block and going through it. And this probably won't take quite as long because there's not as many processes running as there are kernel modules. Sure.
You were saying when you use like the serial cable, everything seems to be a lot quicker and everything works better with that. So have you seen any like difference between using like WinBag or Perl? Like,
yeah, the framework I've done is way slower than WinBag is going to be, just because of the fact of the way I'm working outside of the API and reading instructions. It's not the most efficient programming method, but you could certainly streamline it more than I have and make the Perl probably just as quick, because at some point the bottleneck does become the serial cable. So here we've just got the list of processes, eProcess block for each one, the physical page table block, our process execution block, just a little information about each one and the process time, and then each thread's information. So we have another time for another thing. Microsoft's WinBag tool gives you the ability to import symbols from MSDN, and which is really useful. I don't have that implemented because MSDN is, they kind of make it hard for you to take third-party apps and download symbols. It's possible, but they try to make it difficult for you. So what I did just, in place of that now is gave it the ability to go in and locate an API address just by walking through the processes in the modules and locating an export. So for example, we might want to find out what the load library A address is. So that's in kernel 32. So we can do that here. And so it's basically going to go through again and load in all of the eProcess blocks. And once again, not very efficient. This probably should have been pared down to a single subroutine, but I took a shortcut and went ahead and just made it use the previous subroutine to get all the eProcesses. And then once we have that, we'll go through and walk through the export table and find out which one of those modules has that, and then get the address. And that's something, as far as I know, That's not a standard WinBag feature. I don't know of any DLLs that let you just type in an arbitrary thing and look it up. But you can do it if you have the symbols, because it'll already be loaded into WinBag's memory. But if you don't have the symbol access from MSDN, then you'd have a hard time doing this. All right, so now it's grabbed that last process there on PID 314 just to look at it, and it's reading the PEB, process execution block, and trying to get the list of the loaded modules in that process, searching for kernel32.dll. Again, our serial port is cranking away over there on the VMware. I don't know why it's so slow. It seems like it ought to be faster if it's just a direct socket connection, but there is some sort of bottleneck. All right, so it found an instance and the base address of kernel32.dll at that 77E8000 there, and now what it's basically doing is going through the export table one at a time and trying to match load library A in one of those exports. So it's kind of a slow way to get it, but we do eventually come up with it, 77E8A254. So I've got one more quick demo before we run out of time here, and that is the ability to inject code from the debugger here into the user space of the target system. So in this case, I just have a simple little demo code that it just inserts a message box, basically shell code, into the remote system. So what we did here, I cheated a little bit for demo's sake. It would normally look up message box A, but as you saw, that takes us a long time, and I didn't really have time, so we went ahead and just defined that ahead of time. But after that, it puts that shell code for the message box into the shared user memory space. And then it goes and finds a suitable thread in an Explorer, and it uses an asynchronous procedure call as an APC, which is a concept that allows you to just arbitrarily add code to a thread for it to execute. The next time it goes into an alertable wait state, it will look at that APC queue, and then if there's any code in there, it'll run it. So that's what we've done, is we basically used the debugger to read those memory structures, and are actually, instead of putting kernel shellcode in, we're just directly manipulating the structures in the memory, which is kind of dangerous probably, but we went ahead and did it, and just as an example. So it says that it's inserted that APC into the queue, so we can go ahead and continue the execution, hit G, and we'll probably get one little message to tell us something, and that's a little bit of raw data that probably needs to be interpreted, but we'll go ahead and hit that again, and we'll go back to our VMware session, and it's gone ahead and popped up that message box for us. So we're about to run out of time. So basically, there's only a few features that are implemented in this, and just whatever's part of the API I try to do, and then macros, just as an example. But hopefully, other people will take it and extend it, maybe rewrite it in Python or something, actually clean it up. So we actually rebooted it over the debug console. So I will be available out in the hall if anybody has some questions, because we don't really have any time here, because the next person's got to get up here and start setting up for their talk. So thanks for coming to the talk, and have a good rest of the conference.